Okay, let's read this question together and see how we can solve it. It's a probability question. The Australian sheepdog is a breed renowned for its intelligence and work ethic. That's all not important, okay? It's estimated that 30%, this is the first thing that we're getting, of adult Australian sheepdogs weigh 65 pounds or more. A sample of 20 adult dogs is studied. What's the probability that exactly 10 of them weigh 65 pounds or more? So they want probability. First, we ask ourselves, what kind of experiment is this? What kind of distribution is this? Well, I claim it's a binomial distribution with n, the number of trials. You have 20 dogs that you're taking. Probability of success. Now, success in our case, because we read that we want to look at how many of them weigh 65 pounds or more, weighing 65 pounds or more for us will be what we call success. So X is the number of successes means, how about, listen to this, how about we say that what success means first, and of course X means the, so in this case success in this experiment means that the dog weighs 65 pounds or more. So this is what we mean by success for our experiment. And so we let X be the number of successes. Now, remember that X is always the number of successes in 20 trials is always going to be between 0 and 20 because we have 20 trials. X is always between 0 and n. Okay, and what do we need to do? We need, we are also given, of course, this 30%. This is our P. So probability of success, P of S. So success S, let me just say success, let's call it S. It means that the dog weighs 65 pounds or more. So probability of success, which is little p, we call it, is 30%. But we know that 30% is the same as 0.3. So it's very important that, okay, let me summarize everything. So therefore, the number of trials is 20. P, the probability of success, is 0.3. And we are asked to find what the probability that exactly 10 of them weigh 65 pounds or more. Look again. Find the probability that exactly 10 of them weigh 65 pounds or more. So the probability that the number of successes, X, is exactly 10. This is what we want. Of course, if you want to solve it using the formula, if you remember the formula for a binomial distribution, it will be n choose x times p to the x times q to the n minus x. That is the probability of x. In our case, we have 20. We want to choose how many? 10. So 20 choose 10 times p is 0.3 to the x, which is 10, times q. Oh, remember, just remind you, this q in any binomial experiment is just 1 minus p. And in this case, it will be 1 minus 0.3 is 0.7 to the power 20 minus x. X in this case is 10. We see it here. This is what x, the x that we're looking for. If you use this formula, you will get approximately to 3 digits. We always do with the probability of binomial distributions. You'll get 0.3 0.31. But let me just say one thing here. So look at all of what I've done here, and I would say here, do not panic. I know that some of you might panic because of the formula, of having to remember this formula. But remember, if you have the binomial table, you can just go to the next page, find where n equal 20 in the binomial table, the probability of success. Well, let me write it down again. N was 20, so this is why we chose the part of the table that has n it's 20. P, the probability of success, let me just go back, is 0.3. So you put here P is 0.3. And we need to find that the probability of X, the number of trials, equals 10. Go back. That is exactly what we need to find. So all what you have to do, now that you know that you chose the right N, you now find the right P. P is 0.3, so you take this column from the table for n equal 20, and then you go to the X. You want X equal 10, so X is here. So where is X equal 10? X equal 10 is there. So move with it, move until you reach P equal 0.3. And so you can say immediately from the table, this is a very easy question using the table, this is 0.031, because it's the probability that X equals a specific number, not less than or bigger than or equal, like that. It's only equal. So look at this number here. We got it from the table in a nanosecond, but if you use the formula, of course you get the same number. You are not required to use the formula if you already are given the table. So you should be happy if you are given the table. And I will finish this question here.